Hello, Algebra 2 students. Today we are going to learn about domain and range and increasing and decreasing intervals. We're also going to learn about continuous functions versus discontinuous functions, and that's a concept that will be useful if you decide to take calculus. So a continuous function is a function basically that continues. It has no breaks or holes. A discontinuous function does not continue everywhere. It does have breaks or holes. So looking at your two examples here, we're going to first evaluate whether they're continuous or discontinuous, and then we'll go back and look at the domain and range. I am going to add these arrows here when evaluating the domain and range. So the first one, you can see that you can draw the graph without lifting your pencil. And so it is continuous, and it's continuous everywhere. So it's continuous everywhere, and the reason why is because it has no breaks or holes. Because no breaks or holes. All right, and then the next one you can see does have breaks in it. We're going to say that it has breaks and not holes because if you take a look, there actually are no missing values in this function. So this one is discontinuous. And it's discontinuous at certain x values. So looking here, it's discontinuous when x equals 1, and then again when x equals 2. Because of breaks. All right, so going back, the first question is one we've done domain and range for before, but the second one is kind of new. So let's just do the first one as review. Remember, domain is all the x values. So we're looking at the x-axis to see what x values the function covers. Remember, all the way on the left is negative infinity, and all the way on the right is positive infinity. So because these arrows are going all the way to the left and all the way to the right, your domain is negative infinity to infinity. Your range starts at the bottom and it goes up. Now, if it went down, there would be a negative infinity, and if it went up, there would be a positive infinity. Our function does not go down, but it starts right here where your y value is 0, and it keeps going up until your y value is infinity. We want to include the 0 with a square bracket, but you never include infinity because you can't get there. Now, this next one is tricky. It looks like your domain would have several pieces to it, but you only break the domain if you're missing a value. And if you look carefully at your x's, we are not missing a value. This one's going to start over here at negative infinity, and that one's going to end at positive infinity. And then let's look at the values in between. So my x's go from -2, -1, 0, 1, and then it looks like maybe there'd be a break, but look, this piece picks up where that one left off, so that one keeps going. And then this piece picks up where that one left off, so that one keeps going to positive infinity. So this time my domain is still negative infinity to infinity. For my range, I'm going to start at my smallest y value, which is 0. And on the right side, it does look like we would have to leave out these values, but the good news is it's covered on the left side. So let's just look at the most continuous piece for our range here, going up from 0, 1, 2, 3, 4, 5, all the way up to infinity. Okay, so my range again is 0 to infinity.